Welcome to the video lecture for Chapter 1, Section 6. This is for college algebra, and my name is Jorge Gavillan. So, the objective for this section is solve equations involving absolute value and solve inequalities that involve absolute value. So, how do we solve equations that involve absolute value? So, if a is a positive real number, and if u is any algebraic expression, then the absolute value of u is equal to a is equivalent to u is equal to a, or u is equal to negative a. So solve inequalities involving absolute value. So here we have the inequality absolute value of x is less than 4. And so we're looking for all points whose coordinate x is a distance less than 4 units from the origin. So we see here the figure that we have for illustration, because any number x between -4 and 4 satisfies the condition absolute value of x is less than 4. The solution set consists of all numbers x for which -4 is less than x less than 4. That is, all x in the interval of -4 to 4. So here's the theorem. If a is a positive number and if u is an algebraic expression, then the absolute value of u is less than a is equivalent to negative a is less than u less than a. Also, the absolute value of u is less than or equal to a is equivalent to negative a is less than or equal to u less than or equal to a. So in other words, the absolute value of u is being less than a is equivalent to either negative a is less than u or u is less than a. So let's solve this inequality that involves this absolute value. So we have the absolute value of 2x plus 4 is less than or equal to 3, and then we're going to go ahead and graph the solution set. So then, using the theorem from before, we're going to get rid of the absolute value symbols, and then we're going to have -3 is less than or equal to 2x plus 4 less than or equal to 3. This is similar to what we did with the equations where we have the positive and the negative. So then we subtract 4 from all three sides, and then we end up with -7 less than or equal to 2x less than or equal to -1. We divide all three by 2, and we get -7 halves less than or equal to x less than or equal to -1 half. So the solution set in interval is brackets -7 halves and -1 half, and then the solution set. So here's the solution of the absolute value of 1 minus 4x is less than 5. So here we can see that it goes from -1 to 3 halves. If we were to solve this, this is what we would get. Here we have the absolute value of x is greater than 3. So then we get -3 to -infinity and 3 to +infinity. So here's the theorem. If a is a positive number and u is an algebraic expression, then the absolute value of u greater than a is equivalent to u is less than -a, or u is greater than a. If the absolute value of u is greater than or equal to a, this is equivalent to u being less than or equal to -a, or u being greater than or equal to a. So here's the solution set of 2x minus 5 is greater than 3. And so, let me go back. When we solve these algebraically, what we do, and so in this case here is greater than 3, what we end up having is we end up setting it up less than, let me see something that's great. Okay, greater than 3. So then we would have 2x minus 5 is less than -3. And then 2x minus 5 is greater than 3. We solve both of those individually, and that's how we get these two solutions. And we'll definitely go over this in class. And that's the end of 1.6. Thank you.